Hey guys, what's up? So welcome to the second days of 75 days of hard work challenge of let's say coding challenge. We'll be solving here the coding from lead code. I am using lead code here. So basically the problem is here 141 linked list cycle. So basically we have given a cycle, a linked list, and you have to return what you have given the head and the head of the linked list determine if the linked list has a cycle in it. What does it mean? Basically, it means I'm coming on the one node and I return to the example or to give you more discussions about that. So basically, this is the linked list, and the last node, or the rather say the tail node, will return not null. It will return to rather random node. If that is occurring in your linked list, we'll say true. Otherwise, you will say false. So basically, I am coming on the example. You can see here. If this is occurring, I am returning true. If that is occurring, I am return true. If that is not occurring, so in this case there is no, there is a, I can say rather say there will be only one head and there will be no other node, so that will return false. So there will be, you can see there's a valid index in the linked list and follows. That should be the big of one time and space complexity. So we'll be doing not the brute force. The point is I'll not using brute force, I'll be using here the tortoise approach, and for the most optimal way of using this, how I'll use it. So basically I'll use two pointers on my head. You know that that is called head, and you have given the access of the head, and that is very true. So this will be your slow, and let's say this will be your first, and you know that how to deal with a tortoise approach, that the slow pointers will come on the next node and the first pointer will comes on jumps on the second next node. So if you don't know about tortoise approach, you can literally try search on Google what is tortoise approach, and you can do rather simple problems. And from the tortoise approach, you can do the mid of the linked list, you can do the reverse of the linked list. Rather, you can do any types of problem, linked list problem, using tortoise approach. So basically, in the from this is a questions from the HD sheet of Striper. So I'll do later. So basically, I'll do what I will move the slow to the next node. Let's say this is my slow, and the first will comes on this in the first iteration. Okay, the first iteration slow will come here, first will come here, and the point is what, that is not pointing, that is initialized at head in the initialized state. So I'll remove it. In the second iteration, what will happen? The slow will come here, and the first will comes on, it will comes on here, and it say that there is no next node, and it will come on the, it will follow this link, and it will come on here. So this is the situations of the second iteration. What will be done in the third iteration? Slow will literally come on here, and first will comes on here also. So that is very simple. The first and the second, or let's say slow, it collides. So in this situation, first will be equal to slow. And if this situation occurs, we can easily say that there is a cycle in the linked list. What? Is it true for every types of linked list? You can say that may that is true because the last node is pointing to the second node, so it is true. But no. Let's come on this condition. It is true for every condition. But why you will say that I am true? I am making a note. I am making a note, and it will be pointing to the head. Let's say this is no. It also can be here. I'll be using another color. I think this color will be visible to you. Okay. Okay. So let's see what is done here. I'm pointing the last node, let's say tail node, to the head. So I'll be creating two pointers, slow and first. This is, let's say, slow, and let's say this is first. So the first iteration slow will come on where? Slow will come on here, and first will comes on here. This is my first iteration case. So let's delete this. What will be done in the second iteration case? The second iteration case, slow will be come on here, and first will moves on here. Okay. What will be done in the third iteration? In the third iteration, let's say I'm taking this color. In The third iteration, let's delete this. Okay, in the third iteration the slow wheel comes on here and the first wheel moves this pointer and follows this, and it will, the next is it is the next, and it will come here, on here. This is the, let's say, first. Oops, this was my slow, and the last, and the this iteration slow wheel moves on here and first will collides on here. So slow will be equal to first. So that will be what? That will be a cycle. So how we'll do it? So there will be, you can see that in the lead code there will be a pointer that is pointing to the head. So instead of that you will be doing what? Make it a bit small. I'll be doing what? So in this first case I will make if the head, if the value of head is null. Let's see, if the value of head is null, I'll be returning what? I'll be returning that are false, because if there is no node, or let's say you can make one thing, if there is head of null or head of next equal to null, let's say head of next equal to null, sorry, you can return to false, because if this is my head, let's say this is my head, if the value of head is null, so there is no node, or let's say this is null, so there is no next node, so you have to return false. Otherwise you have to do what? You have to make a two pointers, you have to set two pointers, let's say slow, let's say first. You have to iterate the slow and force, like what? You have to make a conditions. I will be doing the conditions in my code, and no need to think about the conditions. I will not deal with the conditions. I have to do the procedure, or let's say the algo. So I'll do what? The slow, let's say slow, slow will be equal to slow next, literally a base topological approach, and the first will be what? That will be point to first next of next. And doing what? I'll be checking here what? I'll be checking if there will be an if statement. If the slow is equal to first, I'll be returning bro, that is true. Otherwise, that is false. That is a quiet and easy and easiest problem I've ever seen. So let's do it. So this is my let code problem. Okay, I'm making it zoom because in the previous video there is a problem that there is, the video was not in zoom mode. So let's come on point. So the first thing we'll be doing, if the value of, let's say, head equal to null, if the value of head is null, I'll be doing what? I'll be return first. That is very quite simple here. And I'll be making two pointer. I have said, oops, I think, okay, struct list node, let's say I'm making slow, and I'll point to head. Let's say first, I will point to head also. And I'm making what? I'm making conditions, let's say while. I'm making a while condition, let's say I don't care about the conditions right now. I will do what? I will be making slow will be equal to slow of next, and the first is equal to first next of next. That is very simple. And if, sorry, and if the slow will be equal to first, I'll be returning what? I'll be return, otherwise I'll return false. And what is the condition? Basically the condition is very simple. If my first of, I'm showing you what will be the condition, what will be the base condition there. So if the first next, let's say this is my first had come on here, let's say first had come on here, and slow didn't have reached here, so let's say this is my node, let's say this is my node, and one iteration point my slow had reached in any random position, and first it is here, so the first next is null. Let's say the next of first is null. So in that conditions, in that condition. So the first condition is if first next should not equal to null, and what, and the first next of next. What I am saying is because, sorry my own wrong. So basically let's say first is here, okay, and first will be pointing to the next of next. So first next of next is equal to null, so I'll return the same. I'll return the same. I'll be doing what, and first next of next is not equal to, oops, I'll be doing, let's make it on submit. It is accepted and I have submitted it, and it will, okay, so the runtime is very 3 millisecond, and that's mean that beats 98.44% users with C. So that is very optimal. Okay, thank you for watching this video. See you the next time.